Previous class we have discussed all about chapter number 2. So today we are going to recall important topics of this chapter. So our today's summary is theories and experiments related to atomic structure, difference between Rutherford's and Bohr's atomic model, isotopes and electronic configuration. Quote of the day: always look for the positive in every situation. Remember to smile. Learn from mistakes, be resilient, bounce back. Students, our today's objectives are theories related to atomic structure, theories, Rutherford's experiment and hypothesis, main points of Bohr's atomic model, difference between Rutherford's and Bohr's atomic model, electronic configuration and isotopes. Okay. Now, in this figure, you can see timeline of atomic theories. The first scientist who has proposed the idea of atom was Democritus. According to Democritus, atom is the smallest particle. Then Dalton proposed his theory in 1803. Then Thomson discovered electron in 1897. Then Rutherford proposed his nuclear atom in 1911. And then Bohr proposed his electron orbits in 1913. Now, first concept of an atom by Democritus. Democritus is the first person ever to propose that matter was made of atoms and are indivisible. He used a piece of clay to prove this. He cut it again and again and again, and at the end, the part of the matter that he received after cutting, that piece of matter, it is called atomus. That is actually a Latin word, and the meaning of the atomus is not to be cut. Then Dalton started his work on Democritus, that atoms are the smallest division of matter, they cannot be further divided. Actually, Dalton was the first who made a distinction between the basic particles of element and compound. He proposed that particles of elements and particles of compounds are totally different from each other. According to Dalton's atomic theory, all matter is made up of tiny particle. This is called atom. Atoms cannot be created, divided, destroyed, or changed into other types of atoms. Atoms of the same identicals have identical properties, and different elements have different properties. Atoms of the element combine in simple whole number ratio, and when they combine, they form new chemicals. Though there were some flaws in the Dalton's atomic theory, as we have already learned about subatomic particle, according to Dalton, atom is indivisible, but we all know that atom is not indivisible. Atom is actually made up of 3 subatomic particles. Those are electrons, protons and neutrons. Another point, that elements have atoms with same physical and chemical properties, but we all know that there are some of the atoms of element, those have different mass number, and we know them with the name of isotopes. We have earlier discussed about isotopes. At the end of the lesson, we are going to discuss isotopes again. Okay, now on the work of Dalton's, Thomson proposed his model. According to Thomson model, atom is actually a spherical structure that is composed of diffuse positively charged matter in which electrons embedded like resin in a plum pudding. If you can look at the structure of this model, what you will observe that this structure of model resembles with the piece of watermelon. The red part of the watermelon shows the positive dense part of the nucleus, and the black seeds are embedded like electrons are embedded in the nucleus. But if in case we are going to apply this Thomson model, so what we will observe that all the negative electrons are surrounded by positive diffuse mass of the atom. But this theory is not corrected, because mass of the atom, as we all know, already we all know that mass of the atom is concentrated in the center of the nucleus, especially the positive charge is concentrated in the center of the nucleus. Now on the basis of Thomson's discovery of electrons, Rutherford designed his gold foil experiment. In this gold foil experiment, you will observe that there is a beam of alpha particle from where the rays of alpha particle are passed through gold foil. According to the result of this gold foil experiment, you will observe that some of the rays passed straight without any deflection, very few of the rays were deflected at an angle, and some of the rays bounced back. Now in the conclusion, we are going to find out that what were the reason behind deflection of the alpha particle, because if in case we are going to apply Thomson model, we cannot find out the reason. So it means that there were some defects in the Thomson model. So we are going to find out the conclusion based on the gold foil experiment. Now, as most of the alpha particles in this experiment, as most of the alpha particles traveled straight through the foil, it means that an atom is mostly empty space. As some of the alpha particles are deflected by small angles, so it means that the alpha particles and the nucleus is positive in charge because of the repulsion of two positive substances. One is the nucleus and second is the alpha rays, those are also positively charged. So because of the repulsion, some of the alpha particles bounce back. Then some of the alpha rays were deflected backward, that is because of the positive charge of atom are all in the nucleus. It is not diffused in the whole atom. It is only concentrated in the center of the nucleus. Now, according to Rutherford's planetary model, the mass of the atom is concentrated in the center and the electron orbit the nucleus. But Rutherford failed to explain the stability of the atom. He could not explain that why revolving electrons around the nucleus in the orbits couldn't fall inside the nucleus. Then according to Rutherford's nucleus atom, atomic structure should be collapsed after some time, but Rutherford failed to explain the stability of an atom. Developing on the Rutherford theory, Bohr proposed his theory, and according to Bohr's theory, electrons orbit the nucleus without losing any energy. One more thing, that orbits around the nucleus have specific energy. So electrons could move only in fixed orbit of specific energies. Electron's energy level determines the closeness of orbit to the nucleus. So it means that if the orbits are closer to the nucleus, they are lower energy, and if the orbits are far away from the nucleus, they have higher energy. So depending on the size of the atom, the smaller will be the size of the orbit, the smaller energy they are having. The larger will be the size of the orbits, the greater energy they will be having. I think you will be getting my point. So by looking at this structure, what you will observe, that if in case an atom in the first shell, if in case the atom jump to a higher energy level, the atom will absorb energy, and if in case an atom falls from a higher energy level to a lower energy level, there will be emission of energy in the form of light. Now the form of energy that is emitted from the electron, it is in the form of light. So you can see from the size of the orbits, the first shell will be having smaller energy because it is smaller in size and it is closer to the nucleus. In the same manner, the larger shell, the last shell, that is n is equals to 6, it is larger in size, so it will be having higher energy. Okay, now just have a look on difference between Rutherford's model and Bohr's atomic model. So what you will observe, that according to Rutherford's model, mass of the atom is concentrated in the center and electrons are revolving around the nucleus. But if in case you are having a look at the Bohr atomic model, he clearly explained that electrons always travel in specific shells or orbit which are located around the nucleus, and these shells have discrete energy level. They have specific energy on which electrons are continuously revolving. It is based on the Guildford experiment, but Bohr atomic model, it was based on the observation of line spectrum of the hydrogen atom, in which Bohr has observed that electrons only absorb energy when they are jumping to the higher energy level, and they will only emit energy when they are falling from a higher energy level to a lower energy level. Because of that, Bohr absorb a line spectrum. Rutherford model does not describe the presence of discrete energy level, but Bohr clearly described the discrete energy level, and the presence of energy level was proved by the given equation, and we can calculate the amount of energy. Rutherford does not explain the relationship between the orbit size and the energy of the orbit, but Bohr clearly explains the relationship between the size of the orbit and the energy of the orbit. Now our next topic we are going to recall is electronic configuration. So if in case we are going to have a look on this figure, so as we have already discussed that the orbit closer to a nucleus is smaller energy and it has small space, and the orbit that is far away from the nucleus, it is higher energy and it will be having large spaces. So in the previous classes we have discussed the formula 2n2. According to that formula we can find out that how many electrons are placed in a specific energy level. So when we are going to distribute electrons, or when we are going to divide electrons in different energy levels, then by applying that formula we can find out that how many electrons can be reside in a particular energy level. So the process in which we are going to distribute electrons in different energy level, it is called electronic configuration, or in other words we can say that electronic configuration tells that where actually the electrons reside or where actually they live. Okay, now here you are just going to recall that first shell can hold up to 2 electrons, the second shell can hold up to 8 electrons, and the third shell can hold up to 18 electrons. If in case you are going to distribute electrons in subshells, you should remember that s orbital, that is smaller energy and it is the smaller orbit, it can hold only 2 electrons. Then p orbital can hold up to 6 electrons, d orbital can hold up to 10 electrons, and f orbital can hold up to 14 electrons. Again, depending on their size, they have different capacities for electrons. One thing you need to remember, that increasing order of energy is S is the smaller energy level, so it is smaller energy, and F is the larger orbit, so it will be higher in energy. So electron will fill in the order, or electron will first fill in the lowest available energy level. So it means that 1s, starting from 1s, it is going to 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. So what you are observing here, that 4s is filled before 3d. The reason is that s shells are having lower energy and d shells are having higher energy. So 4s, because of smaller energy, will be filled first as compared to 3d subshell. Okay, now just have a look electronic configuration of magnesium. You will observe there are 12 electrons in magnesium. So first shell K, 2 electrons will be there. In second shell you will place 8 electrons, and when you are left at the end with 2 electrons are filled in the third subshell. Yes, now the last topic, not the least but the last topic, is isotope. Atom with the same number of protons and electrons with different number of neutrons are called isotopes. The nuclei of the 3 isotopes of hydrogen, you can see what do they have in similar. They all have 1 proton but the different number of neutrons. As you can see that the first nucleus, it is having no neutron, the second is having 1 neutron, and the third is having 2 neutrons. So it means that they have different number of neutrons and different mass numbers. Okay, when we are going to compare the isotopes of hydrogen, we can find out some of the similarities and some of the differences. So because they are having same number of protons, so there are same number of electrons. As we know that electrons and protons are similar in an atom, that goes to the concept that atom is a neutral particle because of having equal positive and negative charges. Same appearance and chemical properties. So what do they differ in? They differ in their physical properties. The reason different physical properties are because of the different number of neutrons and different atomic masses. Okay, now atomic number is actually number of protons in the nucleus. Mass number is number of proton and number of neutrons. So if in case you are going to find out the mass number, you can add atomic number plus number of neutrons. Here one thing you need to focus on, it isotopes of atom are atoms of the same element that have the same atomic number but different mass numbers. So it means that two atoms of same element can have different mass number. So what we can say that atomic number is the identity of an atom. Okay, so if in case you are going to identify an atom, you should know atomic number of that atom, not the mass number. If in case you are not given with the mass number or you are not given with number of neutrons, there is no difficulty to find out that atom, because atomic number is the identity. If in case you are given the atomic number, you can clearly find out which element is this, what is its symbol, and how many electrons and protons it is having. So you can see there are two examples given. One is the hydrogen and second one is the uranium. Okay, now in this lesson, what we have discussed that in the center of the atom there is a dense positively charged nucleus having electrons moving around in different energy levels. Atomic number is the identity of an atom, as two different atoms can have same mass number but not atomic number. In this example you can see that calcium and argon, they both are having atomic mass 40. Electrons first fill the lowest available energy level. Example, 4s is filled before 3d as it is lower in energy. Now think like a proton and stay positive. Now the assignment you have to do, multiple choice questions from page number 39. Question number 3, 4, 7, 8, 9, 13 and 14 from textbook, page number 40. Question number 13 and 14 will be marked in book. Think tank exercise from textbook exercise you have to do. Thank you so much students. This is all from my side. Inshallah we'll be meeting in the next class soon. Have a nice